For Pre-Calculus Semester 2, the first topic you will be studying is the law of sines. For this lesson, you may want to refer to your unit circle. You may want to print this out and keep it handy so that you can remember the important unit circle angles, the points that are associated with them, and you also want to remember that the sine of the angle is the x-coordinate. So for example, the sine of pi over 6 or 30 degrees, make that as the y-coordinate. Sine is the y-coordinate, so the sine would be 1/2. The cosine is the x-coordinate. The cosine of 30 degrees or pi over 6 is square root of 3 over 2. Tangent is the y-coordinate divided by the x-coordinate. So these are some things you may want to remember from first semester. You might want to pull out those notes and keep those handy. Back in Chapter 4, you looked at techniques for solving right triangles. In this section and the next, you will solve what we call oblique triangles. These are triangles that have no right angles. As standard notation, the angles of a triangle are labeled A, B, and C, and their opposite sides are labeled A, B, and C with lowercase letters as shown in the figure below. So notice that the side opposite angle A is labeled lowercase a. The side opposite angle B is labeled lowercase b. And the side opposite angle C is lowercase c. Solving an oblique triangle requires knowledge of one side and any two other parts of the triangle, either two sides, two angles, or one angle and one side. The four cases solutions to oblique triangles are classified into 4 cases. You can either know two angles in any side, two sides in an angle opposite one of them, 3 sides, or 2 sides and their included angle. The first 2 cases can be solved using what we call the law of sines. The latter 2 cases will require the law of cosines, and you'll be learning about both of these laws in the first couple of lessons for the semester. The law of sines states that if ABC is a triangle with sides A, B, and C, then A over the sine of A equals B over the sine of B equals C over the sine of C. So if we know any two sides in an angle or any two angles in a side, we can solve for one of the missing parts. And this is the case with oblique triangles. 2 different possibilities. Either the A angle can be acute or the A angle can be obtuse. The law of sines can also be written in the reciprocal form, where we put the sine of the angles on the top and the sides on the bottom. So let's look at an example. Given 2 angles in one side. So this is the angle side example. For this triangle, angle C equals 102.3 degrees, angle B equals 28.7 degrees, and side B equals 27.4 feet. We need to find the remaining angles and sides. So because we know the 2 angles, we can begin by finding the third angle. Remember that the 3 angles of a triangle always must add up to 180 degrees. So angle A will have to equal 180 minus 102.3 plus 28.7. If we add those together and subtract it from 180, we're going to find the measure of angle A. So if I add together 102.3 and 28.7, I'm going to get 131. And 180 minus 131 is 49 degrees. So angle A equals 49 degrees. So I'm going to go ahead and label that in our figure. So now we've just got to find side A and side C. So we want to remember that sine of A over A equals sine of B over B according to the law of sines. And I'm choosing B because we know the length of side B. So we can fill in all the known details. We know that A is 49 degrees. So this will be the sine of 49 over A equals the sine of B, and angle B is 28.7 over 27.4, which is side B. To solve a proportion such as this, we're going to cross multiply. So we'll have 27.4 times the sine of 49 degrees equals A times the sine of 28.7 degrees. So now to solve for A, we can divide each side by the sine of 28.7. And then the calculator can be used to simplify this. You're going to want to keep the entire numerator in parentheses when you do this division. And you'll also want to make sure that your calculator is in degree mode. 27 times the sine of 49, I'm just going to do that first and press enter. Then divide that by the sine of 28.7 degrees. And we find that side A equals 43.06. So I'm going to label that in our figure. We now need to figure out the measure of side C. So let's erase and make a little more room. We're going to use the same process. We can say that the sine of A over A equals the sine of B, oh, actually C, we're finding C this time, sine of C over C. So the sine of 49 over 43.06 equals the sine of C, and C is 102.3 over side C. So cross multiplying, we're going to have C times the sine of 49 equals 43.06 times the sine of 102.3. We're going to need to divide each side by the sine of 49 to find C, to get C by itself. And so we find, when we use the calculator to simplify this, 43.06 times the sine of 102.3, all divided by the sine of 49 degrees, is equal to 55.7. So side C would be 55.7 degrees. And for our next example, let's take a look at the situation where we are given two angles and one side, the angle side angle example. A pole tilts toward the sun at 8-degree angle from the vertical. So we see that this little angle, if we went vertically straight upward, we'd be here. This little distance is 8 degrees. It casts a 22-foot shadow, and this bottom edge of the triangle represents that shadow. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. So this is angle A. And we are asked to find how tall the pole is. So that would be side A that we are looking for. So in this problem, we have the right angle labeled, and because a right angle is 90 degrees, to find the measure of angle B is going to equal 90 degrees plus that 8-degree angle. So angle B would equal 98 degrees, and I'm going to label that here now. We've already been given angle A, and we've been given side C. So we're also going to want to find angle C. Remember, anytime you know two angles of a triangle, you can find the third. We know that the three angles must add up to 180 degrees. So to find angle C, we're going to do 180 minus 98 plus 43. And that will equal 39 degrees. So we can now label angle C as 39 degrees. So to find side A, because we know the measurements for both side C and angle C, I'm going to use the sine of C over C equals the sine of A over A to solve for little a. For the sine of C, we're going to have the sine of 39 divided by little c, or side C, which is 22, will equal the sine of angle A, or 43 degrees, over A. And A, of course, is what we're solving for. I'm going to erase our picture to make a little more room. When we cross multiply here, we're going to get A times the sine of 39 equals 22 times the sine of 43. So to solve for A, we're going to divide each side by the sine of 39. And so A will equal, I'm going to use my calculator to simplify from here, 22 times the sine of 43, all divided by the sine of 39, which equals 23.8. So the length of that pole is approximately 23.8 feet.